What is up, guys? Fahir here, and welcome to your very first C++ game created in Unreal Engine. Yes, that's right, we're going to create this game only using C++, no blueprints whatsoever. We're only going to use blueprints to put actors in our game because they're like prefabs in Unity, but we're going to code their behavior using C++. So let me share the game that we're going to create. I'm going to hit the play button. As you can see here, we have a nice spaceship. I can start shooting right away, as you can see. And I have asteroids and spaceships that are attacking me. As soon as I kill one of them, I also increase the score. Pay attention to the top left corner. When they hit me, and also enemies can shoot at me, and these big asteroids, when I kill them, they put out or they spawn new smaller asteroids, as you can see. And when I get hit by asteroids or the enemies, I lose health. Pay attention to the top left corner. You see, I'm losing health. First of all, I'm losing armor, and when the armor is done, then the health comes on the line. And when the health drops to 0, we die. So let's try to kill all of these. I mean, we cannot because they are spawning infinitely. And all of this behavior we are going to code with C++. And pay attention also to the atmosphere in the game. Also, when I kill the enemies, they are able to spawn health pickups. Let me try to kill one of the enemies, and apparently I cannot do that. So I'm shooting like crazy, hoping that I will hit one of the enemies and not die, because then we're going to spawn health pickable items and we can pick them up and, well, increase our health. Come on, man, hit at least one of the enemies. Like, there it is, finally. You see the blue thing? Pay attention to the health at the top right corner. You see now it is being increased when I pick it up. So there you go. And of course, if I die, and let me try to die, so let's try and die, go over here, die, bam. Restart the game, and I can click on the restart button and restart the game and play from scratch. Again, as I said, we're going to code this whole behavior only in C++. We're going to learn a lot of cool things. Even though it's a simple, in quote, space shooter game, we are going to learn a lot of cool things. I believe I have for this, I don't know, for these video series, I have like 6 or 7 hours of content. So you can imagine how much we're going to learn just by coding this game, because there are very low amounts of tutorials online purely using C++ and Unreal Engine. On YouTube, there are none, basically. So yeah, I've created that for you. Thank you very much, Fahir. I know you're eager to create this game while I'm talking still. So Fahir here from Livestream.com. Let's get into the video and start creating this game. What is up, guys? Fahir here, and now that we saw the game that we are going to create, let us do just that. What else did you expect? I'm not gonna be a clown and perform here for you. I'm gonna teach you how to make a game. So let's go over here in Unreal Project browser. Actually, going to open your Unreal Engine. It's gonna open this right here. You're going to click on the new project tab, and this time we're gonna go from blueprint to C++ because we're going to create this game purely using C++ and no blueprints. So you're going to click here on basic code. We are going to select desktop and console, maximum quality, and make sure that you don't have any starter content. As you already know, here you're going to select where you're going to save the project, and here you are going to give the project the name or a name for the project. Then you're going to click on create project. You're going to wait a few moments because it takes Unreal Engine a few moments to build everything up, to compile the code, to prepare the project for you, blah, 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 blah. You get the point. When everything is finished, this is what you will see. This level over here and the content, and over here you will see C++ classes. For now, we have the space shooter game mode or game mode base. Don't worry about that. We will start creating everything, but before that, we're going to import the assets. Now, in order to import the assets, you can download them. Link will be in the description below. So right below this video, you can download the assets, and this is what you will have for the assets right over here. This is what you will see. Project for assets. Now, when you open this, this is actually an Unreal Engine project. So you're going to click on the space tester over here, double click it to open it. And when you do that, you will open it like this. And here you go. This is what you will see when you open that project for assets. Now, pay attention what we need to do. Go over here where it says content. If you don't see it, it's right over here. So you're going to click on this top left corner under the content browser tab. So when you click on that, it will expand and you will see here the content and all of this good stuff. So you're going to click on the content and you're going to right click now and you're going to click on migrate. So on the content over here, right click and migrate. When you do that, you are going to fold everything here. You're going to select the game. So this is the top folder, the top hierarchy folder in the tree over here. So you're going to select that. You're going to click OK, which means we're going to import the whole project. And what you need to do is you need to locate where you have saved your first projects. Let me just go back over here. The first project that you have created, this one, you need to locate where you have saved it. So let's go over here again and repeat everything. And I'm going to click OK. And I'm going to navigate where my project is. Here it is, Space Shooter. And you're going to go inside. And after that, you're going to click on the content over here, which is the content folder. Not go inside, but simply click on that. Click on the content. Click select, and it is copying the files and it is transferring them to our newly created project. And over here, bam, some content could not be copied. Don't worry about that. Everything has been imported. So if I go back over here in our project, this is the one that we have created. You see over here. So we have materials, meshes, music, particles, SFX, starter content, and all of the good stuff. As I said, don't worry about that. As you can see here, we don't need the levels. Levels are not being imported because we're going to create our own levels. And as I said, everything has been imported. Now, this is in regards to this video. I've just prepared the project, imported everything. Starting from the next video, we will create our first level. So don't worry about that. I just wanted to show you how we can import the assets so that you are prepared for the next video. And until then, I will see you in the next video. Where else can I see you? I don't live near you. I don't know where you are, so I cannot see you in person, but I will see you in the next video. In the previous video, we have created our project and we have imported the assets. Let us move forward by creating our level, and we're going to start here in the content folder, and I'm going to right click and create a new folder, which I'm going to call levels. And inside of this folder, we're going to save the current level. So let's go over here under file. You can click on save current or simply Control S or Command S on Mac to save it and select where you want to save it. In our case, it's going to be the levels folder. And over here for the name, I'm simply going to call it gameplay. And I'm going to click on save, and voila, there you go. Now, we are not going to use the level as is. I'm going to delete everything. So in my top right corner on the world outliner, I'm going to select everything over here. So atmospheric fog, blah, blah, blah. Everything except the gameplay editor over here, and click delete. Yes to all, only have an empty dark level now. So the first thing that I'm going to do is add some lighting. And over here in the world outliner, I'm going to right click and create a folder, and I'm going to call this one lights so that I can group my elements that I add over here. And let's go over here in our basic, and here instead of me searching for point lights and blah blah blah, I'm simply going to type here light like this. And here we have the directional light, which I'm going to drag and drop and put right here. First of all, select the directional light and drag it under the lights folder over here at the top right corner. I'm also going to rename it directional light 1, so space then 1, because we're going to have 3 of them. And let's go over here, select the light, and here for the lux, which is the intensity, basically how much pressure or how much brightness will our light have. So we're going to say 5. And for the light color over here, I'm going to click on it. And for the hex linear, let me just select all of this over here. I'm going to say C0 8E3000, and I'm going to click on OK. So first of all, click on enter and then click on OK. I'm also going to reposition and re-rotate our light. So over here for the location X, I'm going to say 30. For the location Y, I'm going to say negative 171, and location Z is going to be 670. And for the rotation X over here, I'm going to say negative 60. Rotation Y is going to be negative 27, and rotation Z is going to be 58. And there you go. This is our first light. We're going to have a next one. So for the next one, simply going to duplicate it. So select it, Control W or Command D on Windows to duplicate it. Now for this one, I'm going to say the position X 40, position Y is going to be 409, and position Z is going to stay the same. The rotation X is going to be negative 60, rotation Y negative 27, and rotation Z is going to be 81. And over here for the lighting, I'm going to say some color, something like this. I don't know, some reddish color maybe, something like this over here. You can, well, selected. This is the color, and simply click on OK, and there you go. It's kind of purplish, not reddish, but let's go over here and try to, I don't know, whatever color. It's not mandatory like that you select the same color as I did. So over here, it's now a little bit reddish. Now moving forward, we also have one more light, but for the directional light 2, for the lux over here, I'm going to say 2 instead of 5. And I'm going to duplicate it, so Control W or Command D again. Now the position X for our light 3, and let me just select, so light 2 is okay, so everything is okay with the position. Now for the light 3, I'm going to select it, and for the location X, I'm going to say negative 420. Location Y 359, location Z is going to be 670. And for the rotation over here, so rotation X is going to be 116. Rotation Y is going to be 47. And rotation Z is going to be 148. And for our color, we're going to make it somewhat dark blue. So selected, and over here in this hex linear, so hex linear, we are going to type 01, 06, and then we're going to say 1200, and I'm going to hit enter, and this is our dark blue color, and I'm going to click on OK, and these are our lights. Now, they don't have anything to show the lights to, or we don't have anything, and let me just save the current to save the level. What we need to do is we need to add our, well, atmospheric field. And in order to do that, I'm going to right click over here and create a folder, which I'm going to call level. So level atmosphere. I'm hoping that I am spelling this correctly, or otherwise there will be people, technically, I don't care. Okay, man, just kidding. But here inside of the modes and in the search classes, I'm going to search for a plane, and I'm going to put the plane over here. And there you go. We have a plane now. Let me just reposition the plane and resize it before we add anything to it. And I'm going to put it under the level atmosphere and rename it to atmosphere plane. So atmosphere plane like this. The position X and Y are going to be 0, and the position Z is going to be negative 350. For the scale over here, I'm going to say X is going to be 16 and Y is going to be equal to 10. And there you go, this is our plane. And as you can see now, the lights are shining on him. If I turn off the lights, you see, they are not shining. So you can see that we have lighting in our game, and I'm going to save this. And now what I'm going to do for our plane, as you can see here, and let me just go and search for the shape plane actually over here. So we have the shape plane, here it is, this is what we want. And here for the material, I'm going to click on it, and we're going to select the background 01 material. This is what we want, and this is going to be our level. Save current, and there you go. Now, we are also going to duplicate this one because we're going to add a star field to it. So simply Control W or Command D, and you see it's like, I don't know, for me at least, it was like shivering a little bit, you see? So I'm going to just move it a little bit, not here, but above, something like this. There you go. And for our atmosphere plane 2, we're going to rename it to star field, not fooled what I wrote. So let me just go over here and set the position for it. So X is going to be at 10, Y is going to be at 10, and Z is going to be negative 210. And for our shape, for the star field, we are going to select over here, and I'm going to filter for background star field. There you go. So this is what we want. And voila, this is our star field. Now, before we add the camera, which is going to show everything in our game, I am going to create the walls, which are going to be the bounds for our levels. I'm going to right click here, create a new folder, and I'm going to call that one level bound walls like this. And for that one, we're simply going to go over here for the modes and classes. I'm going to filter for a cube, and I'm going to drag and drop the cube. There you go. And put it inside of the level bounds wall or bound walls folder, because we're grouping everything over here. And I'm going to select this cube, and I am going to rename it to wall 1. And let me just go over here, and I'm going to set the location of it at 3 for the X. For the Y, it's going to be 100, or actually 1010. And the Z is going to be negative 210. And there you go. This is where our cube is. Now we do need to rotate it, or actually rescale it. So the scale X is going to be 20. and the scale Y is going to be 1, and the scale Z is going to be 6.75. Voila, there you go. This is our first wall. Now, the same way, we're going to create a second wall, so simply duplicate it, Control W to duplicate it, or Command D. Now for this one, I'm going to reposition it, so the X position is going to be at 13, the Y position is going to be negative 1057, and the Z is going to stay the same, and the scale is going to stay the same. For our wall 3, so Command D to duplicate it, wall 3 is over here now, so I'm going to select it. The X is going to be negative for the location, negative 893, so negative 893, that is. For the Y location is going to be negative 35, and for the Z, I'm going to say negative 100 or 210, excuse me. Now here for the X, we're going to scale it at 18.25, Y, I'm going to leave it 1, and the Z I'm going to leave at 6.75, but I'm also going to rotate this bad boy for negative 90 degrees on the Z axis, and there you go. This is going to be our, well, other plane, or actually other bound wall. And we are going to have another one as well. And for this one, so Command D to duplicate it, we're going to have our fourth one. And for the fourth one, I'm going to set the X position to be 881. And the Y is going to be negative 35, so negative 35. The Z is going to be negative 210. The rotation and everything is going to stay the same. And there you go. So let me just Command S to save everything. Let's try to build the lights as well. So click on Build right here next to Compile. Depending on how strong your machine is, your computer, it will take a moment or two to rebuild these lights. And you can already see that, well, the lights over here, and yes, they're now built completely. As you can see now, the lights are different in our level, which is what we want. And voila, there you go. Now, the last thing left for us to do is to add a camera actor, which is going to be our main actor. So let's go over here in the classes, and I'm going to filter for the camera, and there you go. Simply put the camera over here. And now we see what the camera sees, and it's called the camera actor. Now for the camera actor, I'm going to position the X at negative 5. Y is going to be 4 for the location, and the Z is going to be 736. Now the rotation of the camera is going to be negative 126 for the X. For the Y, negative 90, and for the Z is going to be 36, and voila, there you go. Now we're also going to, if I go over here, and if I click on selected viewport, this is what we see when we run our game. So from the selected viewport, don't worry, when we add our character in the game, we will see it from the camera's perspective. So what I'm also going to do over here for the camera, make sure it's set on static, it's not movable, first of all. Now, for the camera settings over here, I'm going to change it from perspective to orthographic, which if you pay attention over here, so let me just go over here. Pay attention to over here when we select the camera. You have a nice little preview what the camera sees. If I change it from perspective to orthographic, there you go. You see now what we see? It's really cool. Now over here, the ortho width, we're going to say at 100 or 1500, which is going to scale the width of what we see with the camera. If you pay attention to what it was before, so let's say if I set it at 500, pay attention to what we see. So if I hit the play button, we cannot still see that because we don't have an actor in our game that we are going to focus on. We will have that when we have the player. But basically, let me just go over here, 1500, I'm going to set that. Here, we're not going to change anything else. That is that. We will see this when we add our character, which is our spaceship, in our level. And in order to do that, we need to start programming our character. So we're going to start doing that from the next video. And until then, firehairfromazdudes.com. I will see you guys in the next video. So the time has finally come for us to start writing C++ code, and we're going to do that by creating our character, and we're going to go in the C++ classes and then space shooter, right click over here and new C++ class. I'm going to click on the pawn, which is going to be the class that we're going to inherit, and the reason for that is because a pawn is an actor that can be possessed and receive input from a controller. To translate that basically means that we can put it inside of our game and we can control it with the input from our code or from the blueprint. But in our case, it's going to be code. So I'm going to click on next, and here for the pawn name, which is the name of the class, I'm going to say ss_player space shooter player, and I'm going to click on create the class, which is going to create it and compile the C++ code and all of the good stuff, and we will be able to use it in our Visual Studio project. Now, important to know, so this is really important for you to know, if you have never coded in C++ before, I highly suggest you, if you are in my Ultimate Game Development Academy, go and watch the course titled Unreal Engine: The Beginner's Guide. And also in the first course, or the outline or the section in the academy, you will see a guideline where I tell you what to learn first. That is the course that I recommend you to learn if you don't know C++, because I cover the basics like variables, functions, classes, pointers, references, that I'm not going to go in depth. I'm not going to explain what they are because I already have that explained. If you are on YouTube, or if you want to watch it on YouTube, you can go and do that. Just type Awesome Tuts C++ tutorials in the search bar, and you will find a full playlist showing you everything. The exact same videos are there as well, teaching you C++ and how to code in C++, and also it will teach you how to connect Visual Studio that we are going to use over here to code with Unreal Engine. So please, if you're a complete beginner, you never did something like that, you never coded in C++, go and do and learn what I just said, either on YouTube or in my Game Development Academy. Now, moving forward over here, you will see and note that we have a .h file. So this one right here has a .h, and this one is .cpp. What is that? Well, basically in the .h file, we are going to declare all the variables that we are going to need or use in our game, such as health, shoot variable, bullet variable, enemy variable, so on and so forth. We are going to declare all that over here, and we are going to use it in the .cpp file. So let's start with that. In the player.h, right here below our constructor, which is ssPlayer, we are going to type or declare our variables. And you can do that also if you don't see this for some reason. You can type it on your own, so you can say public colon and then start to type the variables right below. So what we are going to create first is going to be our uScene component. And this is going to be a pointer, so I need to add an asterisk over here. And if you don't know what a pointer is, again, please go and watch my C++ tutorial series so that you know what is a pointer. So here we have a pointer, and I'm going to call it default scene root. Now we're also going to declare the components that we are going to use with our, or attach on our character. Now over here, I'm going to type uProperty, and inside of parentheses, I'm going to say edit anywhere. Edit anywhere like this. This basically means that the variable that we type over here next, so the next variable that we type over here, we will be able to see it right here in our world outliner when we select that game object or that actor inside of our game. So we will have it like here. For example, we have transform over here. We will have that variable visible there, and we will be able to use it, and so on and so forth. And it's anywhere like this. So the first variable that I'm going to declare is going to be particle system component. So here we're going to say uParticle system component, and it's not uParticle system, it's uParticle system component. It's a pointer, and I'm going to call it particle systems, or simply particle system, however you want to call it. Now you can see over here, if I hover over, it says identifier, uParticle system component is unidentified. If I try to do this, let's go here and build the solution, and the shortcut for this is Control-Shift-S or Control-Shift-B, excuse me, not S, so Control-Shift and B. Anyways, what we see here that it compiled, the build has succeeded, but one issue that we do have here is if I hover over, the particle component is unidentified, which means basically if we try to use it now, it will not allow us because we did not import it over here. Starting from Unreal Engine 4.17, we need to include over here every single component that we want to use. So in our case, we want to use the particle component system. So what we need to do is we need to type hashtag include like this, and in quotes, I'm going to type over here particles, then slash, then I'm going to say particle system component.h. Now, how do I know what I need to include? And I also talk about this in my C++ tutorial series that I have mentioned for you to go and check out. But I'm going to mention here as well, just briefly, how do I know what I need to import? Well, basically, and now, as you can see, the red thing has, or the red line that was below over here is now gone, and we now see a different color for the declaration. Now, what I wanted to say is basically, and ignore this over here, we don't have any issues, but sometimes, I don't know, these don't sync very well. When I say these, I mean Unreal Engine and Visual Studio for some reason, but yeah, we are good to go. Anyways, how can I know this right here? Well, I'm going to take the particle system component and I'm going to go in the Unreal Engine documentation and here for the search, which is, by the way, docs, Unreal Engine com. And over here, I'm going to type it out and simply in the search, and now I have it. It's right here, particle system component. When I select it, it gives me everything, what it has, blah, 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 and explains what are the variables and so on and so forth. I'm not interested in that. What I want to do is scroll way down to the bottom for the header over here. And this is what we want from over here, from particles.h. Now you see here, how do you know? Because we have runtime, engine, classes. If you see classes or if you see public. So if you see classes over here, you can select anything after the class, which is particles, particle system component H, go back in your project and simply paste it over here. And there you go. Now, every single time you see red line below a component that you're using or something that you're declaring over here, you need to do exactly this that I just showed you. But moving forward, I'm going to import everything that we are going to use inside of our player H class. So I'm not going to do it like on the go. And also one important thing to note is that you see over here, when you start your project, you will have everything like this. Now you cannot do this. You cannot do include over here. I believe that this will not even build. Let me just test it out. So Control Shift and B, just for me to see if this is going to build or not. And as you can see, it didn't build. You see, succeeded 0, failed 1, as you can see right over here for the build, which means we cannot run this project. It has an error. Now the reason for that is inside of the .h file, this right here, the class name, so SS player is the class name, generated H file needs to be the last inside of this include statement. So over here, if you want to include something new, you need to include it above your class name generated H. Make sure that one is the last or it will not work as you just saw. So what is the next step? I'm going to go here and include, and inside of quotes, I'm going to say here components / and we are going to have static, so static mesh component, and not instance, but this one right here, static mesh component, and end the statement. I'm also going to copy this from here and paste it. So next, what we have is a capsule component. So I'm going to say / capsule component H and end that in quotes, by the way. So make sure that you end the quote as well. So over here we have components again, / and we are going to have an audio component.h because we are going to, and make sure that you add a semicolon to end the statement, because we're also going to have an audio component and we're going to use all of that we have just imported. Now moving forward, I'm also going to copy this because we also want the next variable editable and visible in the world outliner. So the next one is also going to be a particle system component. So I'm simply going to copy this. It is a pointer as well, and I'm going to call it explosion FX. Now below, let me just again copy this. We are going to have static mesh component, and it is going to be a pointer, and I'm going to call it ship mesh, which is going to be our ship. We are going to select the ship. And moving forward, again, we're going to have, let me just copy this, for some reason it did not paste. So after our ship mesh, we're going to have a capsule component. So you're going to say capsule component. It is a pointer again, and I'm going to call it collision component because we're going to use it for our collision. Now paste again the U property to edit it, and here we're going to have capsule component, or actually, excuse me, not the capsule, but the audio component. So audio component, again, it is a pointer, and I'm going to call it that explosion sound. So these are the components that we need, that we are going to use and add. Of course, we're going to add more variables. Don't worry about that, but that will come just a moment. We are going to go now in our player.cpp. And as I said, here we declare what we need to use, such as the particle systems, explosion, ship mesh, so on and so forth. But over here, we implement that. And I'm going to implement that right here inside of our constructor. Now this right here is called the constructor. I talk about that inside of the C++ tutorial series. So if you don't know, please go and watch it so that you understand what I'm doing here. The constructor will be called when an object is created from this class. And I also talk about that in the C++ tutorial series. So over here, what I'm going to do is I'm going to call our root component, and I'm going to say it's equal to create default sub-object, and we are going to create uScene component like this with the name. So we're going to say here text, and the name of it is going to be, and here I'm going to say colon, or actually quotes, and I'm going to call it root component like this. Now we're going to do the same thing for R. So I'm going to copy this because we're going to do the same thing for the ship mesh and other components. So over here I'm going to say ship. So what did I do? Actually, not paste right now. So I'm going to say ship mesh is going to be equal to, we're going to create a default sub-object, but it's not going to be uScene. It is going to be uStatic mesh component. And with the name, we are going to call it ship mesh like this. And let's go below. We're going to have our particle systems. So particle systems, that is, and it's going to be equal to create default sub-object component. And over here, I'm going to say particle system component. Here it is. And we're going to call this one particle system, not with an S, but with simply particle system. Now, again, I'm going to copy this over here. Actually, I'm going to copy this whole thing. So for the particle systems, and here I'm going to say explosion FX. So I'm going to say explosion FX because it is also a particle component system. And over here, I'm simply going to call it explosion FX. And let's move it forward. I'm going to move this below. And from here, I'm going to copy this. And here in between, I'm going to say collision component is going to be equal to create default sub-object, and it is going to create a uCapsule component with the name collision component. So here I'm going to say collision component like this, and right below the last one is going to be our death explosion sound. So I'm going to say death explosion sound is equal to create default sub-object, and it is going to be uAudio component with the name death explosion sound. So here I'm going to say death explosion sound like this. Now you're wondering, what the hell is this? Well, we will see in a moment. I need to type it out first so that we can, see what it is. So what we need to do now is we need to add every single one of these components to we need to add all of these components, as I said, to our root component. So what we need to do is we need to type here ship mesh is going to be, or actually from it, we're going to say forward dash, or actually simply dash, and then this greater than sign. This is how we call functions on a pointer, because over here, if you remember in our player.h, the ship mesh over here, here it is, the ship mesh, it is a pointer. So we need to do exactly as you just saw. So this is how we call functions on a pointer. And I also talk about that in the C++ tutorial series. So here, what we're going to do is we're going to say attach to component. And where are we going to attach it? We are going to attach it on the root component, but we also need to provide the F attachment transform rules. Basically, what are the transform rules? Are we going to keep our own transform, or is our transform going to be relative to the root component? So over here, I'm going to say F attachment transform rules, and I'm going to say colon, I'm going to say keep relative transform, and there you go. And we're going to do the exact same thing for all of our other components. So over here, actually above the ship mesh, I'm going to paste 1, paste 2, paste 3, and we have 1, 2, 3, 4, 5, and paste 5. So here above, we are going to have the collision component. So here I'm going to say collision component. We have the ship. Now we have the particle system over here. Next, we have the that explosion sound here. And lastly, we have the explosion effects over here. So simply select all of these and voila, there you go. So now what I'm going to do, Control-Shift-B to compile all of this, because we cannot run, I mean, we can run, but we will not see all these changes if we don't compile. And as you can see over here, and let me just see, unexpected, detect, expected, what did I type over here? Let me just see, this is on line 10, 9, and 10, 11. Let me just see, so 10, 9, and something here I missed. So components, capsule component, .h, and over here, actually, I added semicolons, which is not something that I was supposed to do. So yeah, remove the semicolons. And you saw also an example of debugging. We saw the lines that caused an error, which showed which error we had. And I'm glad that this happened because you saw how I quickly debug something. So I simply went over here and I saw, well, stupid me, I added semicolons. So let's try it out. Control-Shift-B to compile this, and you will see now when it's compiled that the build has succeeded, so on and so forth. But it takes time, as you can see, it takes some time, and voila, the build has succeeded, as you can see. Now, another way to compile this is also going in Unreal Engine and pressing here compile. You will also hear a sound. Let me just pump the volume to hear, for you to hear the sound. I'm going to, keep it quiet. So that is the sound that I was talking about. You will hear it when the compile is done. And when it fails, you will hear like, something like that. That was my error compilation sound. So yeah, enjoy it. Anyways, now we have everything over here and I can explain line by line what this is. So let's go back here in our content. I'm going to right click and create a new folder for the blueprints. So blueprints. Now please don't go like, don't be, teacher, but you said we were going to do everything in C++. Why the blueprints now? Calm down. We cannot add our C++ class inside of the root scene, or actually in scene right here, because it doesn't work like that. Our C++ class will be attached on a blueprint. So let's go over here and right click and create a blueprint class, which is going to inherit, and we're going to click on this drop down list for all classes. So click on it to inherit. And here in the search, I'm going to say ss_player. Voila, here it is, the player that we have just created over here. So we are going to inherit from the player, ss player that is, and I'm going to double click it. So select it. Why isn't it allow me to select it? Let me just see now. Finally, so click on it and select it. And this is going to be our ss_player_BP for blueprint. So we have inherited from our class over here, which also inherits from the pawn class, as you can see over here. Now, what we can do now is we can go over here and double click it to open this blueprint. And let me just dock the blueprint here in the project. Now pay attention what we have here. We have the root component, it says inherited. We have the ship mesh inherited, particle systems inherited, collision, explosion, blah, blah, blah. All of that is inherited. Basically, we did this VI code. So everything here that we typed, we created the ship mesh. If I go back over here, here it is, the ship mesh. And if I hover over, notice it's a static mesh component, which will allow us to now attach a static mesh on it. And if I go back over here, this is how we do it. We declare it over here inside of the .h file. So here it is, our ship component. Let me just find it over here. Here it is, ship mesh, which is a static component. And then we create it over here by calling create default sub object and passing here which is that sub object that we are going to create. It's a use static mesh component because here we declare it to be that same type. And then we give it a name over here, ship mesh, which you can see right here. So that is what we did. And in order for us to attach all of these components on this blueprint pawn game object, we need to call this right here, attach to component, because if we don't call this, then we will not have all of these components over here. And this right here, F attachment transform rules, keep relative transform. We are basically telling this ship, for example, ship mesh, we are telling to keep its transform. If I click here in the details and I click on this drop down list, and over here we have the transform. So if I click on it, it is telling this component to keep the transform relative to the parent that we added it to. So when we move in our game, it will move along with the parent. So this is what we did. Now finally, let us go over here for our static mesh, and we need to add the mesh. So click on the drop down list for the static mesh, and over here we are going to filter, and we are going to type rate like this, and here it is, rate radar starship. Here is our starship that we are going to use. Compile and save, and let me go again, select the component over here. Now for the transform, I'm going to set the Y to 56 and the Z to -249. And I'm also going to do what? I'm also going to rescale it, or actually I'm going to re-rotate it. So for the X rotation, I'm going to say 180, and for the Z rotation, -180. And we're going to scale it inside of our game, not here. So we will scale it later. Now, what is the next step that we are going to do is we are going to attach our particle component. So let's go over here, particle system, select it, click on the drop down list here in the details. So click on the drop down list, and let's go over here to particles. So which particles are we going to select? So click on it here, and what we have is player ship thrusters. So this is what we want, and it's basically like, as you see, we're going to simulate that our spaceship is like, you know, it has fire behind it. Now we need to rescale this bad boy, so I'm going to go over here inside of the transform, and for the scale X, I'm going to say 7.3. For the scale Y, 7.3, so 7.3, and the scale Z, 7.3 to resize it. And also I'm going to reposition it. So on the Z axis, I'm going to say the Z location, that is, it's going to be 13, which is going to put it right over here, as you can see, which is going to simulate, as I said, that we have fire behind the ship when the ship is like flying. So compile and save that. So the next step is our collision component. Click on it. And over here for the collision component, we have the shape. We also have the transform. So for the transform of our collision component, I'm simply going to say here for the Z location is going to be -186. So -186. But we do need to resize our component. So over here, I'm going to set the half height of the capsule to 288. And the radius, I'm going to say 130 and hit enter, and voila, this is our ship. So you see the capsule, it is circling the ship, which is going to allow us to detect collision, so on and so forth. Now, moving forward, we have the explosion effects over here. So let's go on the particles and also on the transform. So for the particles, we are going to select the P explosion. So select the P explosion. And we are going to simply rescale it to 3, 3, and 3 on X, Y, and Z. And if I compile and save that, you will see that they will explode right away. You see, bam, they have exploded, bam. And last but not least, we have our that explosion sound, which is our audio component. And over here for the sound of the audio component, click on the drop down list and for the sound as well. And the sound that we're going to select is explosion 1. So let me just filter for it here, explosion 1. Here it is. So explosion 1 sound wave, compile and save that. And voila, there we go. So now we can go inside of our game and I can simply put our ship over here, and here is our ship. Now we are going to resize it. Let me first select the player BP, and over here for the location X, I'm going to say 0, location Y is going to be 71, and the location Z is also going to be 0. For the rotation X, I'm going to say 90 degrees, for the rotation Y 0, and for the rotation Z, I'm going to say 90, which is going to position our ship like this. If I were to go now and click play to play the game, this is what we see. And we want our ship to be, well, a size smaller. So let's go over here, and I'm going to click on the lock icon for our scale. And when I do that, I'm going to type the scale for the X.1, and it's going to set the scale. And did I select the lock icon? So let's now do 0.1. And for some reason, it didn't do. Let me just go back. So now I'm going to select again, player BP, click on the lock icon, and over here, scale, I'm going to say 0.1, and automatically it's going to set the scale for all three of these. I don't know why it didn't right away. Maybe I clicked away from it and I didn't notice. It's not important, but when you click on the lock icon and you change one of these, it will change all three. So now we have our ship smaller, which is what we want. And if I click play, You see, this is what we have. Now, another thing that I want to do is I want to go inside of our code, and for our player, we want to set auto possess, and right here, that will happen inside of the constructor. We want to auto possess our player. Now, the reason for that is because if we go here in the project settings and maps and modes, and over here for the selected game mode, you see we have, or we cannot select the default pawn, we cannot select the player controller, the game state base, blah, blah, blah. We will create our own default game base. Don't worry about that. We will create it. But as I said, we cannot, the possessed pawn is not our player. If I click the play button and shift and F1 and eject myself, you see, we have, this is the default pawn and the player is over here. We want the player to be the default pawn. So what we need to do is inside of our code over here, I'm going to say auto possess player, as you can see. So auto possess player is equal to auto receive input, as you can see, and we need to say here colon, so colon, and we need to say player 0. Now, to make sure that this works, we also need to go over here inside of the player SSBP and select the top player game object, or the top parent, this one right here. And when you select it over here in the pawn, so let me just find it, here it is, our pawn. And here for the auto possess player, you need to click on this disabled and select player 0. Compile and save that. And over here also we need to compile the project because I did not compile it from here. I added this new line of code. Basically anything new you add to your C++ code, you will need to compile it either here from the editor window inside of Unreal Engine, so clicking here compile, and you saw here at the bottom right corner compile was complete, or from here by going under build and build solution, or as you can see the shortcut is Control-Shift-B, and you will probably see the shortcut for macOS as well. So now if we go back over here and if we try to test this out, so if I click play, again we have an issue. And the issue is, if we go back and select the camera actor, you remember we set all of these settings, so we positioned it, we did this orthographics on and so forth, but over here for the auto player activation, which is basically if I hover over, specifies which player controller, if any, should automatically use this camera. So basically, which player is going to use this camera to show him. So here we are going to click on disabled to player 0, and let's go and save, and Control-Shift-S to save everything. So if I click play now, bam, you see how we see our level, which is really, really cool. We have our player, which is here. We are now seeing him. And if you remember, when we set our level up, I said here for the camera actor, I set the ortho width, it was to 512. And if I click on it to 512 and click on save and play, you see how we are very close to the player. So basically, if we select the camera and ortho width, if we set it to a higher number, we are like zooming in or out, or we are telling the camera what we are going to see. And now if I go back and click play, this is what we see. Here is our player in the middle. We see our nice level and we are showing that with the camera. And again, in order to make the player focused, we did this over here, auto possess player, which means that now the player that we have possessed, if you remember a moment ago when I ejected myself, we saw that I ejected myself from a sphere. But if I go over here now and shift F1 and click on eject, you see over here, I'm basically ejected myself from the player because the player, and you don't see the sphere anywhere. You see, the sphere is not visible. We don't have it because the one that we are auto-possessing is the player game object itself. And of course, in the player SSBP, we selected it in the pawn here. We need to say that he is player 0 because over here we're possessing the player 0. And if we want the camera to watch or look at that player, we need to tell it that here, activate for player is player 0. Now, also one thing that I want to show you, which will clear this over here up, is if I go back over here and if I right click and create a blueprint class, and let's say it's a pawn one, and I'm going to call it tester underscore BP. I'm going to delete this later on. This is just a test. You don't have to do this, just watch, and I'm going to double click it. Now, pay attention here. You see, we have the root component, we have everything. As you can see, we have the ship, particle system, collision, blah, blah, blah. And over here, we don't have anything. Well, I can go over here and click on add component, and I can add a static mesh. Here it is. And I can select this mesh over here. I can go and I can select my spaceship Raider, or however is the name of this spaceship, as you can see, and here it is. And compile and save. And I can also go over here, add a capsule collision, and click on it, and here is our capsule collision. So let me just zoom in on it. Here it is. And I can resize it and do everything we did over here basically, but we did it via code. And how we do it, we first create a default sub-object, specify the type, the name, and then we attach it to the component. So we call attach to which component? So we want to attach it to the root component, and you will see that all of these are children of the root component. If I fold the root component, we don't see any of them. So this is what we did in our code. Anyways, if something is not clear, make sure that you ask in the comment section below, and I will help you out. And I will delete this blueprint. I just wanted to show you what we did via code, what we can do with the blueprint as well. So far here from usdudes.com. In the next video, we will start moving our spaceship. And until then, I will see you in that video. Moving forward with our game, we are now spawning our spaceship in the game, and let's start moving it. In order to do that, we need to go into the project settings and then go here in input, and we need to create action and axis mapping. Now for the action mapping, I'm going to click on the plus over here. This is not something new. We did this already in our other Unreal Engine courses. Basically here we're going to create an action map which we're going to use in our code to detect when we press a certain key. So I'm going to call that one fire. So this action map is called fire, and it will be detected when we do what? Well, I'm going to use a mouse, and I'm going to use the left mouse button. And I'm also going to go over here, click a plus button, this right here, which will add a new source here that we can detect. So I'm going to go under keyboard, and I'm going to find the key K. So when I press the left mouse button or key K, then I'm going to fire or call the action map fire. And we're going to detect that in our code. Now for the action mappings over here, I'm going to click on the plus button. And here we are going to have our first one, which is going to be move right. And it's right. And I spelled it correctly. I thought I didn't spell it correctly. And for the move right, we're going to add here under keyboard, we're going to have the key D and click on the plus button again, and we're going to have key A. So keyboard, and let's find here key A. Now for the key D, we're going to leave the scale at 1, and key A, I'm going to set the scale to be equal to -1 because I want to, when I press the key A, I want to move my spaceship backwards. When I press D, I want to move him forward. I'm going to click on the plus button again and add a new axis mapping, and inside of the new one I am going to call it move up. So here I'm going to say move up, and here for the first one I'm going to find W under the keyboard, so key code W, and click on the plus button again, and over here for the next one keyboard, and we're going to find key code S. Let me just find it over here. Voila. Now for the W, I'm going to set here -1. And for the S, I'm going to set it to be equal to 1. And of course, I'm doing this because I want to move our spaceship up and down. That's why we need to have a negative and a positive scale for the specified axis mapping. And of course, as I said, we're going to detect this in our code. Now, let's go in the code and start to bind all of this together. So I'm going to go back over here, and inside of the player.h, I'm going to declare variables starting here where we declared our last property, which was our audio component. I'm going to declare all variables and functions that we are going to use, even though we're not going to use them right away in this video, but I'm going to declare them all so that I don't come back and forth to declare all the variables. So the first that we need is going to be a U property, and I'm going to set here edit anywhere like this, not apply mirror, edit anywhere, and it's going to be float field width. Now we are going to use this to restrict the movement of our player, because we are going to, well, basically not allow him to go outside of these bounds. And let me just lower my volume. By the way, if I pump up the volume, you also hear, did you hear the explosion sounds? Let me just try it again. So you hear that explosion sound. We're going to turn it off as well. So don't worry about that. And let me just go again, click play. I'm not going to allow the player to go outside of the camera view here, here, or here. So we need to strict him. In order to do that, we are going to have the field width and of course the field height. And let me just copy this because again, this is also going to be the U property edit anywhere, which will allow us to edit it in the right here details panel. So actually in the world outliner, excuse me. So let's go back, and over here we're going to have float, and this is going to be our field height like this. So field width, field height. We are also going to have our properties that we are going to edit inside of our blueprints as well. So here I'm going to copy this, but here instead of edit anywhere, I'm going to call here or type blueprint read only, because I'm going to allow this to be read inside of the blueprint only. And the reason for that is because you saw that in order for us to create our character, our spaceship that we are going to put in our game, we created a blueprint. Now we will need this in order to get this value inside of the blueprint later on when we create the UI for our game. So this is going to be our float maximum health like this. And I'm going to copy all of this over here, and let's go below and paste it. And here I'm going to say instead of maximum, this is going to be the current health. And also there's going to be blueprint read only. We're also going to have the maximum armor. So here I'm going to say armor, and below I'm going to paste it again. And here this is going to be the current armor, because we are, as you saw from the preview of the game, we have the armor that is protecting us before we start to lose our health. This is that. Now moving forward, we are going to have our functions for the moving left and moving right. So over here I'm going to say void move right, which is going to take a float axis value, which is going to be this right here. Let me just go back and in the project settings, and let me auto save everything. So you see here we have the axis mapping and we have the scale value, as you can see. Well, this scale value, -1 and 1, depending on A, D, W, or S, we are going to pass it right here in the axis value. Now you will see right away over here when we declare a function that you see this green line, and if I hover over like this, and if I right click and say quick actions and refactoring, you will see here create definition of move right in SS player CPP. So we need to declare a definition of that function. Now, even though if we don't declare it, we can still run our game with no errors. So don't worry about that. We will declare these when we need them one by one. So moving forward, we also need move up. So it's move up like this. And again, here we're going to have an axis value as a float parameter that we are going to pass. Now we are going to have more functions such as void fire weapon. We're going to use it to fire the weapon. We are also going to have void start firing, as you can see, and void stop firing. So stop firing. Now, again, we are going to implement some of these functions in this video and code them, but some of them not. But so that I don't go back and forth, I'm going to declare them all right now. Now, we're also going to have a U property with editable anywhere. So I'm going to copy it and paste it, and this is going to be our float maximum velocity by which we are allowed to move. We're also going to have boo B is firing. Now this B in front of it is basically Boolean is firing as a shortcut. That's like a standard in C++, well, for Unreal at least. Now moving forward, we're also going to have a float weapon fire rate, so fire rate. And also we're going to have a float time since last shot, meaning time since we have last took a shot or fire a projectile. Moving forward, we're going to have a bool hit, and we're going to have a bool be dead to indicate if we are dead and if we got hit by an asteroid or our spaceship or the projectile from the spaceship. Now, since we have the maximum velocity, we also need to calculate the current velocity so that we know how are we moving. So we're going to have float current x velocity like this, and we're going to have a float current, so current underscore y underscore velocity like this. We're also going to have a blueprint read only property again. So let me just copy this over here and paste it right here below, because we're going to have a float player score to indicate the score that we have. Now we also need to know our current location, and we're going to denote that with the vector. So here we're going to have f vector, not vertex, it's f vector. And I'm going to call this one current underscore location like this. We're also going to have f rotator, which is going to be our current underscore rotation. And we are going to have f vector new underscore location. Now don't worry, as I said, we will use all of these. Don't worry about that. That will come. Every single one of these will be used, and we will again explain them, so on and so forth. Now over here, I'm going to create a u function, which is basically we're going to denote that we have an event that's going to be fired. And here I'm going to say void on begin. So on begin overlap like this, and we're going to have here an a actor, so a actor like this, which is a pointer, and this is going to be our player actor, and again another a actor, which is again going to be a pointer, other actor. Now if you watched any of my other blueprint Unreal Engine courses that I have inside of my academy, we use this on begin overlap a lot. Now we used it a lot, and the reason for that is because we are going to detect when two objects collide. For example, if an asteroid hits us, we are going to know that by calling on begin overlap. Or when a spaceship, enemy spaceship, is colliding with our own spaceship, or when the bullet from the enemy hits us. So this is how we are going to do that. And don't worry, we have only two more variables and we are done. One is going to be edit anywhere. So let's go over here, edit anywhere, and I'm going to call that one, or we're going to type T subclass of, and here we're going to say a projectile like this. And I'm going to call that one weapon projectile underscore BP. Now we still did not create this. We will, so I'm going to comment it out. This is going to be for our projectile, which is our weapon. Don't worry, I will call it, or we will create it, but for now just comment it by using double backslash. And basically when we comment something out, this will not be compiled by the compiler. We will not be able to use this in our code, or actually we will not have any errors or whatnot. I can type something like here, I can say hello Carl, and since I did this with a comma, or actually with a comment, this will not be compiled and we will not have any errors. And the last function is going to be collectible pickup, which is basically going to be the function that is going to be called when we pick up a collectible item. So let's go over here and select these two functions. So we have the move right and we have the move up. So I'm going to select them, and you can either click on this light bulb over here and click on create definition, or click on them and right click, and over here actions and refactoring, create definition, bam. You will see now it automatically created this definition in player.cpp. If I go back over here and scroll down, here it is. Void a as player, move right, float, axis value, there you go. So it has created the definition of this function that we have declared over here. So now we are not complaining, or C++ or Visual Studio is not complaining as it did before. So let's right click on the move up and click on here, create the move definition, and let's go and check it where it is. So it's right here below our move up, or actually move right, which is really cool, which is what we want, because this is what we are going to use to bind these functions to these inputs over here. So to these inputs. Now we need to bind them, as I said, and that happens over here. You see, in our player set up player input component, it has this player input component as a parameter that we're going to use to bind these. And you see here, called to bind functionality to input. So basically here, what we are going to do is we are going to say player input component, which is this right here, which is the parameter that's being passed. And you see here, it's a pointer. So it has an asterisk, it's a pointer, which means we need to say minus sign or dash and then greater than sign to call a function. And we're going to call bind axis. And here, what I'm going to do is I'm going to say fname, the name of the function I want to bind, and the name of the function is going to be in quotes move right, and I'm going to bind it to where? Well, this, or where is this function located? This function is located in this, meaning this class, this player.cpp class. It has this move right function, and I'm going to, well, now pass the function. And how we're going to do that? Well, simply by copying this over here and using the and sign and simply passing it like this. And voila, there you go. Now, don't worry if this gives you an error. You input component call to bind pointer to incomplete class type, not allowed, blah, blah, blah. Don't worry about that. Everything is fine. If I go here, Control-Shift-B to compile all of this, you will see that we will not have any errors. You will see that it will say build has been completed, but as you know, we do need to wait a moment or two, and well, the build has failed actually. And the reason for that is, I'm going to tell you right now, which is really cool. I wanted to cover this as well, but pay attention over here. You see, this is the error. Link error 2019, unresolved symbol public void, onBegin overlap, blah, blah, blah. Now, the reason for that is when you declare a function that's going to be bind to an event, such as our own here, onBegin overlap, you do need to create it right away, or actually go over here, right click, quick actions and refactoring, create definition, and automatically it has created that definition, which is, let me just find it, it's right here. Here it is, onBegin overlap. So let me just take onBegin overlap, and actually I'm going to move it from here and I'm going to move it below. So over here, I'm going to move it below all of these axes. Now, the reason for that is because this is going to be bind to an event that's going to be called, as I already said, which is begin overlap. Don't worry, we will cover it, but I'm telling you that when you declare uFunction, which means we are telling that this is going to be bound to an event, and this allows the delegate system to access this function because we are binding the delegate to it. We need to automatically also implement it over here, even though if we don't want to use it, or otherwise you saw the consequence, we cannot build our project. So let's Control-Shift-B to build the project again. And now you will see that based on this error player input component, this is what I wanted to show you, that that is not a problem at all. So you see over here, bam, build has succeeded. Now the reason, and probably somebody will ask me, so I'm going to answer it right away. The reason why we see an error here is that simply sometimes these connections between the Visual Studio and Unreal Engine are broken because Unreal Engine is a bit complex, so on and so forth, yada, yada, yada. So that's not our fault, it's their fault. This is what I'm telling you. Moving forward, I'm going to take this over here and I am going to copy and paste it, and I'm going to bind here. So I'm going to say bind move up, and over here I also need to call move up and bind the move up as you just see. This will bind the input axis with the name move up, move right, and move up. And let me just go over here and tell you these. So these are those that we are binding, move right and move up. So these are the axes that we are binding, and we are binding them where? Inside of this, basically in this class. So this is the class where we are binding them, and we are binding them to this function over here and over here. Essentially, move right, if I go over here, which means this right here, move right, will be bind to the move right function, which means when we press A or D key, or D or A key in this case, this right here will be called. And when we press the W or S key, this right here will be called. So what is going to happen in our move right when we call that? So what are we going to do? Well, basically over here we're simply going to take the current X velocity, so current X velocity, and we're going to say it's equal to the maximum velocity multiplied with the axis value. That's all there is to it. And for our other, which is, and let me just move this like this and copy this. For the move up, we're going to do the same thing, but here instead of current X velocity, we are going to say current Y velocity. And again, we are going to use, as you just saw, we are going to use the maximum velocity multiplied with the value. So let's define our maximum velocity. I'm going to go quickly here. We have our player SS, which is our constructor right here below. We are going to say here maximum velocity. So maximum velocity is going to be equal to 250. So 50.0 F. Now we need to add F at the end because our maximum velocity, if I go back over here, let me just find it. Our maximum velocity, where it is, here it is. It's a float. So in order to denote a float, we're adding F at the end. We're also going to say here current X velocity. So it's current X velocity is equal to 0.0 F. I'm simply going to copy this. This is declaration. We're declaring, setting the initial values. So this happens in the, as you can see in the constructor, which will be called when the player is spawned, because when we create a new object, a constructor is called. Current x velocity is also going to be equal to 0. Now I'm also going to set here B is firing to be equal to false by default. Our weapon fire rate, so it's weapon fire rate, here it is going to be equal to 0.25 f. And we are also going to have time, since last shot is going to be 0.0 f. Now we are not going to use these right away, don't worry, but I'm just declaring them here, and our player score is going to be equal to 0.0. Don't worry, we will come back to these as well, so don't worry about that. Now inside of our begin play, you see called when the game starts or when spawned. Now inside of the begin play, we first need to get the reference to our current location. As you can see here, we have the current location and current rotation. We need to get that reference. So over here, I'm going to say current location is going to be equal to this, referring to this game object, referring to the pawn holding this script. So we are going to say this minus sign greater than sign, and we're going to say get actor location, which is going to give us the current position in space where our spaceship is. And notice here I'm saying this because it's a pointer, and we are getting the get actor location. Now going back to current rotation, so let me just type it correctly. So it's current rotation, it's equal to this dot get actor rotation. Same way, it's very simple. We did this in our blueprints in my other Unreal Engine courses. We did this with the blueprint. This is how it looks like in code. So next I'm going to say here B hit. So B hit is equal to false, and our B dead is equal to false. And our explosion, if you remember a moment ago, I showed you that. If I go back over here, let me just raise the volume just a little bit up. You heard the explosion, right? You're not deaf. Why am I asking you? Because you did hear it. So we're going to turn it off. And also, not only you heard the explosion, but you saw it. Notice, you saw the explosion, which is the explosion effect. So we are going to deactivate that. So we are going to say explosion, FX, and dash and greater than sign. We're going to say deactivate. So it's actually deactivate like this. We're also going to say that explosion sound. And again, over here like this. And we're going to say deactivate. There we go. This is going to take care of that we saw a moment ago. Now our maximum health and so here I'm going to say maximum health is equal, not maximum align, it's max health is going to be equal to 100.0. The current health, so current health is going to be equal to also 100.0. The maximum armor, so maximum armor is going to be equal to 100.0. And the current armor is going to be equal to 100.0 F. Now we can also leave it 100 point or 100.0. It will also work. It's the same thing. And basically that is that. The last thing is left for us to do is simply inside of our tick, get the input. But also here, what I'm going to do is I'm going to call on actor begin overlap to bind the function that we have over here. Let me just find it. Here it is, our on begin overlap. So over here, what we are going to do is simply going to type add dynamic. So dynamic, don't worry if it doesn't pop up. Simply type add dynamic. And over here, I'm going to say this. And here I'm going to say and sign ASS underscore player. And here colon on begin overlap, not on begin cursor, on begin overlap, which is going to bind the overlap with our player. And that is that for setting up our player. And inside of the tick function, which is called every single frame, so the tick function is called every frame, we are going to test the current velocity. So we're going to say here if the current x velocity is not equal to 0.0 f, or if our current y velocity, and again here, change x to y, and we're going to test if y is also not equal to 0.0 f, which means we are pressing the buttons over here that we have bind by these components, which will set the current x to be equal to this value and current y to be equal to this value. So if they are not equal to, this or, double pipe sign means or. Basically, if this is true or if this is true. So this can be false, but this is true. That means the if statement here will be executed. And I covered this in my C++ tutorials. So go watch that. And basically, if the current x velocity is not equal to 0, or if the current y velocity is not equal to 0, so either or, this will not execute over here only if both of these are not true. So only if both are false, it will not execute. So if that is the case, we're going to say new location, and it's new location, it's going to be equal to f vector. And here I'm going to say current location dot x, and I'm going to say plus to it, and this is for the x location. I'm going to add to it current x velocity multiplied with delta time, and delta time is basically this right here with the float. You see float delta time, which is passed here in the tick function, which basically means that this is the value between every frame. So we have 60 frames in a second. The time between frames is the delta time. So we're multiplying that to have a smooth movement. Now here I'm going to say comma, not dot, but I'm going to say comma. And for the y, we're going to have the current y location. So current location y, that is. So here we're going to have current location dot y. And we're going to say plus to it. And here we're going to pass the current y location. And let me just find it. Paste this here. Make sure that instead of x we have y, so current y location or current y velocity, excuse me, multiplied with delta time, again same as what we did. And here we also need to say comma and then 0f, or simply 0, which is for the z axis. So for the x and the y, we set here current location x plus the current velocity, and the current location y plus the current y velocity multiplied with delta time. And basically that's that. Now, the last thing, we simply need to reset our location. So we need to say this, and here we need to say set actor location, and we're going to pass the new location. And basically it's this right here. Let me just copy it, and there you go. And the current location is also equal to our new location, because we need to set that up in order to have a new location set up. You see, current location, we need to set it to new location because we're using new location to move our player. And basically that's that. So Control-Shift-B to compile all of this. And wait for it to compile because it takes time. Unfortunately, it's not my fault. I have nothing to do with that. And bam, build has succeeded, as you can see, which means we are good to go and test it out. Let's go back over here and run the game. So now if I try to move the player, you see, bam, he's moving up, down, forward, backwards. And the reason for that is, again, because of the inputs over here. So I was pressing the ASD key, so DAWS. So I was pressing those keys, as you just saw. Again, if I go back over here, let me just go back in the gameplay. Pressing the W key, moving up, pressing S key, moving down, pressing A key, moving backwards, pressing D key, moving forward, pressing A and W, you see over here. And now we can go outside of bounds. As you can see, we're going out of bounds. As you can see, we're going to streak the player in the next video. Don't worry about that. But again, briefly, what we did, we created over here these action mappings, move right and move up. We bind them, we actually declared the functions over here, first of all. So here they are, move right and move up. So we declared those functions. Moving forward here in our player.cpp, we bind those functions by using player, and you can see it's still red. It's still red for some reason. I don't know why. Again, it's not our fault. We cannot do anything about it. So here we have player input component. We are binding, which axis we are binding? We are binding the move right, which is this one right here. Move right, that's it. That is the name. You need to, the name over here, capital M, capital R, move right needs to match up with the name over here. If, for example, you have here move right with lowercase r, it will not work. So make sure that the capitalization, simply copy and paste it over here. So we are binding the axis with the name, move right. Inside where? Inside of this class. This is referring to this class, meaning player.cpp. So this is referring to this class. And the function that we are binding this axis to is our move right, which means when here, move right, when we press one of these keys, this function will be called. Same as for move up. And inside of move right, we're setting current velocity is equal to maximum velocity multiplied with the axis value. Here we have the current velocity y, doing the same thing. And over here, we are over here, inside of our tick, we are testing if the current x velocity is not equal to 0.0 and current y, which means we are not pressing. If they are not equal to 0.0, actually that means we are pressing the buttons, be that the A key, D, S, or W. Either can work because of this or sign over here that we have. And here, when that happens, when we are pressing one of these keys, the new location is equal to the current location, and we get the current location over here because we need to have the current location where our actor, where the spaceship is located. There you go. We're saying current location, this is equal to get actor location. And then we are setting current location x plus the current x velocity multiplied with delta time to smooth things out. Because if we use current x velocity with a large value, and since this is being called every frame, if we have 60 frames in a second, our spaceship will just, like shoot like a rocket. We will not even see it. That's why we are smoothing things out. And our current location y plus current y velocity multiplied with the delta time, this is setting the new location or calculating the new location. Then we need to set it to our actor. So this, again, referring to this class or the actor holding this class, which is our spaceship. Set actor location, new location that we have calculated. And since in the next calculation we will need the new updated current location, we're setting current location is equal to new location, and that is that. And minus these variables that we set up, so excuse me for that, I had to do it so that I don't go back and forth, that is the only reason. But again, when we go and progress with this course, with this video, with this game that we're creating, we will revert back to all of this here and I will explain it again and yada yada yada. You saw that this works. I'm not going to repeat it again because this video is already long. Fire here from usdudes.com. I will see you guys in the next video. Moving forward with our game, we are now moving our spaceship, and if I hit the play button, you will see that we are moving, but he is going out of bounds, and we are not rotating him when we are moving him up and down, because I want to slightly rotate him on the y-axis when I move him up or down, which is going to have this really nice in-depth effect. So let's cover that. Let's go back here inside of our player.cpp, and right here below, after we test our if statement for this, we are going to rotate our spaceship. And in order to do that, again, we're going to write another if statement, but let me just here tag the tick function so that I know where it ends. So if I click on this here, we will see that, you see here, it is ending, indicating that it here begins and here ends, so that we don't get lost. So what we're going to do here is I'm going to test if, so if the current y velocity, so current y velocity, which is this bad boy over here, if it's greater than 0.1 f, meaning we are moving on the y velocity, so we started to move. That means moving upwards because it is greater than 0.1. What we're going to do here is we're going to say this set actor rotation, not transform, but actor rotation like this. And we need to pass the F rotator because he is the one responsible for rotation. So F rotator, here it is, F rotator. And what I'm going to do is we are going to say here current rotation. So current rotation, here it is, dot pitch. So we're getting the pitch rotation. We're going to say plus 45.0 F, 45 degrees to rotate it. For the yaw, we are simply going to say current rotation yaw. So here I'm going to pass current rotation dot yaw, not add, but yaw, like this. And going back over here, we're going to simply say current rotation dot roll, and there you go. Now, for those of you wondering, what is yaw, what is roll, what is this? And here also, excuse me, we need to add one more end parentheses to end the statement, because over here we have set actor F rotator. Is it only one? Let me just see what I did over here. So F rotation, current rotation, actually, excuse me, we need to take this over here like this. And we need to say here, comma, and put the current yaw over here and take the roll. Let me just delete all of this here and hit enter and add roll over here. So all of this happens inside of the F rotator. So excuse me for that. So we have the current rotation pitch plus 45 F. then we have the current rotation yaw, then we have the current rotation roll. Now let me just go quickly over here, and if you select, for example, our spaceship, which is our SS player BP, and for the rotation, if I hover over, this is the roll value. If I hover over here, this is the pitch value. If I hover over here, this is the yaw value. So X, Y, and Z. So moving forward, here I'm going to say else if, let me just find where my cursor is, else if the current y velocity, so I'm going to take this, if the current y velocity is less than, so if it's less than, but we're going to say negative 0.1, which means that we are going down. What we're going to do is I'm simply going to copy this, so take it and copy all of that, and simply over here we are going to say minus 45F. That is all there is to it. Else, meaning if neither of these is true and we are not doing anything, we're simply going to do this. So I'm going to copy this over here, F rotator. And for the F rotator, I'm simply going to pass here the current rotation, and there you go. Because the current rotation, if I go over here, we are getting it. As soon as we start our game, we are going to get the current rotation, which is the default one basically. So if the current y velocity, it's not greater than 0 and it's not lower than negative 0. And when I say greater than 0.1, I said 0, but greater than 0.1 and less than negative 0.1. So if neither the case is here, then we're going to go in else and we're going to reset the normal rotation. Control Shift B to build this, and let's wait and see if we did everything correctly. If we did, we are going to build it. If not, we are going to, probably my computer is going to explode. You're going to yell at me and I'm going to start a panic, but everything's okay. So yeah, so we build it. Let's go back over here and test it out. So pay attention now, the depth of the spaceship. You see how he's rotating? Do you see how that looks cool? And let me just go over here, Shift and select the player SS, and pay attention to his rotation. You see? Pay attention to the rotation. We are rotating the pitch. Notice it's the Y rotation. So look at the rotation. It's 45 when we go up. When we go down, it's 45 positive. When we go up, it's 45 negative. Pay attention, and you can see, you see how he is like, you know, I don't know how to explain it, but you can see what I mean. Now, the next step is, as you can see, we are going out of bounds. You see, we are going out of bounds. And, well, that's not something that you want to see in your game because, well, how can you play your game? So let's go over here inside of or below. So going below from this over here. And let me just move this. Actually, I'm going to leave it like this. I just wanted to in-depth this a little bit more, but maybe this one over here can do. And over here, what we are going to test is, we're going to say if this, referring to the spaceship or the object holding this class again, so this is referring to this class, and we're going to get the actor, I have issues talking, so we're going to get the actor location, so get actor location, and we're going to get the X location if it's greater than the field width. So if it's greater than the field width, we are going to do what? We're going to set the current location. So we're going to say current location is going to be equal to F vector. And here I'm going to take the field width and I'm going to say -1 to, well, give it just, you know, to remove it from the width, which basically means we are, if this right here, let's say these are the bounds, and our spaceship gets close to here and it's going to try and go outside, we're going to say minus, and you can see field width -1, which means it's going to position it over here. So it's going to move it from here to over here, basically not allowing it to pass that point. So it's not going to allow our X position to be greater than field width -1. And next, we're simply going to say current location Y. So over here, current location dot Y and current location dot Z. So current location dot Z, finally. Thank you, God. There we go. And what I'm going to do is I'm going to put this like this over here and remove the one curly bracket. Now, what's happening over here is, and here I'm saying F, but actually I'm simply going to say 1. Remove the F over here. So essentially here, notice we have only one line after the if statement. And I talked about this in my C++ tutorials. If you only have one line after the if statement, you can omit the curly brackets. If you have more than one, then you need to have curly brackets. So moving forward, this is going to strict our player when he tries to go on the positive side. Here I'm going to say if this, and like this here, I'm going to say get actor location, like this dot x. If it's less than the negative field width, which means if we are going to the positive side, so we're going to do exactly the same thing over here, but instead of -1, I'm going to say +1, and there you go. We are also going to test for the y location. So if this, and getting the, so get actor location dot y this time. If y is greater than field width, or actually, excuse me, if it's greater than field height, which is great. So here we have field width. Make sure that here we have field width, and here it's field height. We're going to say current location. Let me just copy all of this. So current location, and here I'm also going to say current location dot, what did I do? So let me just take this over here, and it's current location. So here we're going to paste it, and it's current location dot x. There you go. So what we're going to do here is we're going to take the current location y, and we're going to remove that, and here we're going to say field height -1, and simply copy this over here. So copy all of this here, and here we're going to test if it's less than, so if the current get actor location y, if it's less than the negative of the field height, then over here what we are going to say is we're going to say negative field height +1. And also here, which I forgot to do, is we need to say negative field width +1, because we're testing that. So this is what we are testing. Because again, over here we're testing if it's lower, so if the current x location of our spaceship is lower than the negative of the field width, then we need to say here negative field width +1. And here we're testing positive, so we're saying positive, -1 in this case. And over here, if our y location is greater than the height, we're going to say field height -1. And if the y location is less than the negative of the field height, we're going to say negative field height +1. Now, Control-Shift-B to compile this and see if we have everything set up correctly. And also, let us just wait for it to compile a moment or two. Unfortunately, it takes like this. It's not like in Unity where you simply hit save and you go back and everything is great. But what we need to do is if I were to run this now, it's not going to work. If I simply run it, you see, look at the issues that we have. It's not going to work. Now, the reason for that is, if you remember, let's go quickly over here. In our player.h, I have created, so let me just find it where they are. They are right here. Field width and field height. Here they are. We did not put them anywhere over here. We did not set their default value in the player.cpp, so their value is 0. But notice here, I set uProperty edit anywhere, and I said, if you remember, now we are going to break down everything that we talked about piece by piece until everything is clear and you are a master C++ game developer in Unreal. So pay attention over here, uProperty edit anywhere. I said that this uProperty edit anywhere will allow us to see this variable inside over here in the world outliner, actually here in the details. So actually in the details when we select in the world outliner. So in the details, if I select the SS player, notice now we have the particle system, we have the explosion, we have the ship mesh, collision, death, sound, and notice field width and field height, and also maximum velocity, pay attention, is 250. So here for the field width, we are going to set a value, and also for the field height. So field height is going to be 400 and the field width is going to be 700. And save that current, so Control-Shift-S to save all, or File, and then go over here, save all levels, or actually go over here and save all. And there you go. So now we have the width for 700 and height for 400, which means now if I hit the play button, now I can move. We don't have the error. But pay attention, if I try to go above, notice I can go up to there. I'm still holding. Notice my ship is rotated, but I cannot go above because that's the bound. Going down, I'm still holding down. Notice I'm holding down, but I cannot go above that or below that value. Going backwards, this is where I can go backwards. You see, up to over here. I cannot go. You see, I'm trying to go, but I cannot. Let's go forward. Let's try to move forward and see where the bounds is. Let's go over here. This is the maximum I can go with, or inside or forward, that is. And if you're wondering how do I know these values, well, I just tested them out. So test out, put here 600 if you want, or 300 for the height. That is on you. You can test and experiment with that. It's not mandatory that you use 700 and 400. So you can test and you can experiment. But again, if I go back, what we did over here, we explained when it comes to the rotation, if the current y velocity is greater than 0.1, or if it's lower than negative 0.1, we're going to rotate, set actor rotation. We are rotating on the pitch, which is the y rotation. So the pitch is the y rotation. So we're adding 45 to it if we are going up, and if we're going down, we are subtracting 45 from it to rotate the spaceship. If we are not rotating, set the current rotation, which is the default rotation that we have over here. As you can see, we're getting in the beginning here, the begin play, we're getting it. So we're storing it, which is the default one. So here we will simply set the default rotation back. Now here, if our current X location is greater than the field width, then we're going to set the current location. And why current location? Because over here, when we are moving, we're setting the new location by using the current location. So our current location is our own location. That's why we're setting that. So current location for the X, since we're testing on the X, if it's greater than the field width minus 1 to subtract it. You can also say, for example, field width minus 10 and test that out. Because if you say minus 10, for example, if this is the bound, and if you say minus 1, it will bring the player here. Maybe minus 10 will bring the player over here. It will not allow him to go below or above beyond this point over here. So you can test that out. If it's lower than the negative of the field, then the negative of the field width plus 1 to not allow it to go above or beyond that point on the left side. Same thing for the Y location as well. If something is not clear, please ask in the comment section below. And Fire here from OzTunes.com. I will see you guys in the next video.